Download this code from codegive.com, link in the description below. Sure. Let's dive into the Raft consensus algorithm in an easy to understand way without getting too technical. Raft is designed to manage a replicated log across a distributed system, ensuring consistency and fault tolerance. Here's a step-by-step breakdown. What is Raft? Raft is a consensus algorithm that helps a group of computers, or nodes, agree on a common state, even if some of them fail. It is widely used in distributed systems to maintain a consistent state across replicas. Raft is designed to be understandable, which is one of its main advantages over other consensus algorithms like paxos. Key concepts: 1. Leader and followers. Raft operates in a leader-follower model. One node is elected as the leader, and the others are followers. The leader handles all client requests and log updates, while followers replicate the leader's log. 2. Terms. Time in Raft is divided into terms. Each term begins with an election. Nodes can become a leader, candidate, or follower during a term. 3. Log. Each node maintains a log of operations, like transactions. The leader's log is the source of truth, and followers replicate the leader's log. 4. Election. If a leader fails, a new leader must be elected. Nodes become candidates and request votes from other nodes. 5. Append entries. The leader appends new entries to its log and then sends these entries to followers. Once a majority of nodes acknowledge the entries, they are considered committed. 6. Safety and liveness. Raft ensures safety by guaranteeing that if a log entry is committed, it will eventually be present in the logs of all nodes. It ensures liveness by making sure that there is always a leader to handle requests and that elections happen in a timely manner. How Raft works. 1. Initialization. When the system starts, all nodes are followers. If a node doesn't hear from a leader for a certain period, it becomes a candidate. 2. Election process. A candidate increments its current term, votes for itself, and requests votes from other nodes. If a candidate receives votes from a majority of nodes, it becomes the leader. 3. Log replication. The leader receives client requests, appends them to its log, and sends append entries RPCs to followers. Followers append these entries to their logs and send back acknowledgements. 4. Committing entries. Once the leader receives acknowledgements from a majority of nodes, it considers the entries committed and notifies the followers. 5. Handling failures. If a leader crashes, followers will eventually start a new election. If a node becomes unreachable, the system can still continue functioning as long as a majority of nodes are available. Code example: pseudocode. Here's a simple pseudocode representation to illustrate the flow of Raft. Note that this is not complete code, but rather a simplified explanation of the main components. Plain text. Class node. State equals follower. Current term equals 0. Log equals def receive underscore request, request. If state equals leader. Append to log. Log.append, request. Send append entries to followers. For follower in followers. Send underscore append underscore entries, follower, request. Else. Forward request to leader. Forward underscore to underscore leader, request. Def election. State equals candidate. Current term plus equals 1. Votes equals 1 vote for self. For node in cluster. If request underscore vote, node. Votes plus equals 1. If votes majority. State equals leader. Notify underscore cluster underscore of underscore leadership. Def append underscore entries, Follower, entries. Append entries to followers log. Follower.log plus equals entries. Send acknowledgement back. Send underscore acknowledgement, follower. Summary. Raft is a consensus algorithm that simplifies the process of achieving agreement among distributed nodes. It does this through a clear structure of leadership, log replication, and systematic handling of failures, making it easier to understand than other algorithms. By breaking down the main components and processes, you can grasp the essential workings of Raft without getting overwhelmed by the code or complex concepts. If you have further questions or need clarifications, feel free to ask.